Hey guys, this is the section 20 video, factoring by using special product formulas. So we've seen some of these already in either 15 or 16, but we haven't seen all of them. So in this video, you'll see all of the special product formulas that we need to be able to use to answer questions in this course. So again, as a review, here's our factoring robot. We will start with a factoring question. We will factor out any GCFs that might be present from the entire problem. Then we'll ask ourselves, well, how many terms do we have? And in this section, we'll be dealing not mostly, but we'll be dealing with anything in these two boxes. So in some problems, we'll have 2 terms. In some problems, we'll have 3 terms. But if you have 2 terms, these will be the 4 formulas we're going to have to deal with. If you have 3 terms, these will be the 2 formulas that we have to deal with. The formulas will not be given to you on the test. It is your responsibility to know them, to memorize them. And sadly, unfortunately, there is no other way to do these questions. You just have to know the formula. So please make sure you know them and you're not sort of using inappropriate means to go through the homework. So we start off with 8 plus m cubed. There is no GCF here because this doesn't have an m. And there's a coefficient of 1 here. So we're moving past the GCF. Then we look at, well, how many terms do we have? We have 2 terms. So that means I have to somehow be able to convert my problem or reframe it either as a sum of squares, which means there's going to be a plus in the middle, a difference of squares, which means there's going to be a minus in the middle, or a sum of cubes, plus in the middle, difference of cubes, minus in the middle. So how do you know which formula to use between the squares and the cubes? Well, the cubes have 3's in them. The squares have 2's in them. And hopefully that's clear enough. And in this particular case, we have a sum of cubes. Well, m is cubed, but what is 8 the cube of? 8 is the cube of 2. So we know that this can be rewritten as 2 cubed plus m cubed. And now this is, in fact, a sum of cubes. We have a sum, we have 2 things being added, and the 2 things being added are cubes. So the formula we have to use here is a cubed plus b cubed equals a plus b, a squared minus ab plus b squared. You have to know this formula. Without knowing this formula perfectly, there's no way to solve this question. I can't, there's no shortcuts. Even if you go online on YouTube and try to find other ways to do it, there simply isn't another way to do it. You have to know the formulas. Now, knowing the formulas means, well, that's 1/3 of the battle. Then you have to know what your A is and what your B is. So A is the thing that's being cubed. Well, 2 is the thing that's being cubed. So I know A will be 2. B is the thing being cubed. Well, in this problem, m is being cubed. So B ends up being m. So all we have to do is follow our recipe. 2 cubed plus m cubed will equal a plus b, 2 plus m. A squared, well, that means I have to square 2. So that will be 4. Minus, the reason why it's a minus is because that's what the formula tells me. I have to use a minus there. A times b, so now I got to multiply these two. A times b is just 2m, 2 times m. Plus b squared, which means I got to square whatever's after the plus. So m squared. Oops. That's my answer, nothing else to it. Now, if the question had said 8 minus m cubed, we would rewrite this as 2 cubed minus m cubed. And we will use the difference of cubes formula, which is the same thing as the one as the sum. But if I have a difference, then this sign is a minus and this sign is a plus. That's the only difference. So the algebraic terms are the same. So here, I know that my answer will have a 2, it will have an m, it will have a 4 here, it will have a 2m here, and it will have an m squared here. What is different is if a sign is a minus in the problem, you'll have the same sign here. So this will be a minus. When we had a plus, this was a plus. the sign on the middle term in the trinomial is always the opposite of the sign in the problem. So because we started with a positive, this sign was a negative. Clean this up again. So because we are starting here with a negative, this sign will be a positive. And then this sign is always positive. So hopefully you're seeing that you can actually get twice as much work out of just knowing one formula. Because if I give you 8 plus m cubed, the answer is the same as 8 minus m cubed with two signs being different. For number 3, we have 8c cubed minus 27. So again, there's not going to be a GCF. I'll let you figure out why. And then we have two terms. So we look at, well, which of these four formulas applies within the two terms? I can rewrite 8 as a cube of something. C is already a cube of something, and I can write 27 as a cube of something. So what can we write as 8? Well, I can write it as 2c, the quantity cubed, minus 3 cubed. And we can verify that this works because the 3 would apply to the 2 and to the c, and you'd end up with 2 cubed, c cubed. Well, 2 cubed is 8. So I know that I haven't broken anything here. Everything is identical. I haven't changed anything. And now the formula applies. A minus b times a squared plus ab plus b squared. So a minus b, a in this case is 2c, b is 3. So the answer would be 2a minus 3, because that's a minus b. A squared, now I got to square whatever this is. Oh, I'm sorry, 2c. So 2c times 2c would be 4c squared. Then I have to multiply these two, because that's going to be a times b. 2c times 3 is 6c plus 6c. And then b squared. 3 squared will be 9 plus 9. That's it. Now, if the question had said 8c cubed plus 27, then you know the answer has to have a 2c, it has to have a 3, it has to have a 4c squared, a 6c, and a 9. This sign will be the same as the one in the problem. This sign will be the opposite as in the problem, and this sign is always positive. So that's where you actually get more efficiency out of knowing the formulas. You only have to memorize them for one type, but you end up being able to solve two types of questions with just one formula. These two are the same. This is just the sum of cubes, so it's exactly the same formula as the one we've used before. Now, 6 and 7 look different, so I'll do 7. 7, there's no GCF because the leading coefficient is the coefficient of one of the terms is 1, and this term doesn't have a u and this term doesn't have a t. So I know that there's no GCFs here. I have to move past that. Now, which of these four formulas could we apply here? Well, right off the bat, we can rule out anything with a sum in it because the problem has a minus in the middle. So the only choices we have are difference of squares or difference of cubes. Now, hopefully you remember this property that when you have, say, x to the 5th raised to the 7th power, when you have a power raised to another power, we multiply the powers together. So this would have given us x to the 35th power. We can go in reverse as well. If we have x to the 40th, we could break apart 40 into two factors and say, oh, this could have come from x squared raised to the 20th. Or it could have come from x to the 5th raised to the 8th. Because 5 times 8 is 40, 2 times 20 is 40 as well. This could have even come from x to the 10th raised to the 4th power. So you can break apart terms into a product of two powers, and that's exactly what we have to use to our advantage here. 9 can never be written as something squared because it's an odd number. You can't multiply two things, one of which is a 2, and get 9 as the answer. You won't be able to do that. We can use 3. So what we could do is rewrite u to the 9th as u cubed cubed. And I can take 8 t to the ninth and rewrite this as 2t cubed. Because now if we multiply these two powers together, we get u to the ninth. That's good. If we multiply 3 to that power and 3 to this power, we get 2 cubed t to the ninth, and 2 cubed is 8, which is exactly what we have there. So we know that this sort of breaking apart of powers is going to give us exactly what we're looking for, which is that. So what we can do is rewrite this problem so that it becomes a difference of cubes. This becomes u cubed minus 2t cubed. Now, isn't this something cubed minus something cubed? That's a difference of cubes, which means we can apply the difference of cubes formula now, which is, well, hopefully you know this by now, a minus b. So u cubed minus 2t cubed times a squared. So u to the third squared plus ab, u cubed times 2t cubed plus b squared, 2t cubed squared. And now we can clean this up a little bit more. So this would give us u cubed minus 2t cubed. U to the third squared, we multiply the powers and we get u to the sixth. Plus u and t's are not the same base, so I can't do anything with them. So this would just be 2u cubed t to the third. Plus, and now we can square both of these terms. So 2 squared would be 4, t cubed squared would be t to the sixth. This is also a difference of cubes. This we can rewrite as s to the third cubed plus 1 cubed. Hopefully that makes sense, how you would rewrite a ninth power as something cubed raised to the third power. This would be the same thing, 1 cubed minus y cubed. That's a difference of cubes. This would be a sum of cubes, s cubed to the third plus d cubed to the third, and then you would use the sum of cubes formula on that. This would be s cubed to the third minus 1 cubed. So again, you can use the difference of cube formula on it. Now we get to something slightly different. We can use, or we have r to the sixth minus 64. Coefficient is 1, so no number as a GCF. This doesn't have an r in it, so no GCF. And we'll look at how many terms we have. Well, we have 2 terms, so we can write this as either a sum of squares, a difference of squares, a sum of cubes, or a difference of cubes. The question becomes, which one do we use? Well, it's a difference, so it can't be a sum. Hopefully that makes sense. There's a minus here, so the sum formulas are out. Now, can we rewrite r to the sixth as r squared to the third power? Hopefully you see that, because I can multiply these two powers and get 6 as my answer. So that works. And then 64 is 4 cubed. So you can rewrite this minus 4 cubed, and voila, you have a difference of cubes. Now this one I'll actually do because I want you to see something as we proceed through this question. So with this, we can rewrite this as r squared minus 4, a minus b. This is a minus b. And then we have to have a squared plus ab plus b squared. Well, a squared would be r squared squared. So that would be r to the fourth plus a times b. Well, r squared times 4 would just be 4r squared plus b squared. 4 squared is 16. That's my answer. Or so you might think. Hopefully you also see this little guy here, r squared minus 4. R squared minus 4 is a difference of squares. So with any of these problems, anytime you use a formula, this part will always be prime, this part will always be prime. So you never have to be able to factor those. You will never be able to. But whenever you use the difference of squares formula, this might end up itself being a difference of squares. This might end up being a sum of squares. This might end up being a difference of squares based on what A and B are. So coming back here, A is a square and B is a square. 4 is the square of 2. So what you need to be able to recognize here is that, oh, I can actually factor r squared minus 4 into r plus 2 times r minus 2, because that's the difference of squares formula. So the actual answer to this problem is r plus 2, r minus 2, r to the 4th, that's not a 4, r to the 4th plus 4r squared plus 16. And again, this part, this part you will never be able to factor further. So you don't even have to look for that. For the sum of cubes or the difference of cubes formula, the trinomial, the 3-term part that you get, you will never be able to factor that, regardless of what the individual terms are. But this binomial that you get at the beginning, you may or may not be able to factor it. Now, why did we not do that right here? Well, because maybe u cubed, actually, we can think about it. This is a cube. T cubed is a cube, but 2 is not a perfect cube. I can't cube something and get 2 as the answer. Now, if this 2 were not here, then absolutely we could use the difference of cubes formula again on u cubed minus t cubed, because that is a difference of cubes. But while that 2 is there, I don't have access to it. Looking at a couple before, 2c plus 3, well, I can't really factor that. It's not a difference of squares or a sum of squares or a difference of cubes or a sum of cubes. Same thing with 2 minus m or 2 plus m. I can't factor those further. They're already as simple as they get. So hopefully that makes sense there. A to the 6 minus s to the 6, you can rewrite this as a squared to the 3rd minus s squared to the 3rd. You can use the difference of cubes formula on this. And then when you do, you're going to get a squared minus s squared times a to the 4th plus a squared s squared plus s to the 4th. But lo and behold, this is now a difference of squares, just like the very last question we did. 9 is 3 squared, 64 is 8 squared, and then x squared is, well, x squared. So what you can do is rewrite 9 minus 64x squared as a difference of squares. And now you can just apply the formula a plus b times a minus b. So this would factor to 3 plus 8x times 3 minus 8x. And that's it. That's done. Nothing else to be done here. 17 is the same as 16. So think about what could you square to get 121? So it would be something squared minus what could you square to get 81x squared? That would go there. And then hopefully you see difference of squares. So you can use the difference of squares formula to get that answer. Moving on. This is difference of squares. This is also a difference of squares, difference of squares, difference of squares. Here, I guess I'll just share a quick thing. You can rewrite this as x squared squared minus 4 squared. You can apply the difference of squares formula, but for something like this, you actually end up having to apply it twice. So the first time when you factor this, you'll get a plus b times a minus b. And hopefully you know from the factoring robot, a sum of squares is always prime. I cannot factor that further. So this first beginning part, x squared plus 4, I can't factor it. It's prime, it's done. But what about this part, x squared minus 4? Well, that's a difference of squares again. So this will give us x squared plus 4, x plus 2, x minus 2. Hopefully that makes sense. Now for 23, this is an example problem where exactly the type of thing that I warn people comes up. The first thing you want to look at is always a GCF. if you ignore the GCF, you actually will say that this problem is prime when it actually isn't. If you were to factor out or recognize that 3 is the GCF here, you always start with the GCF and you're going to be left behind with 25x squared minus 1. And now you see, oh, this is a perfect square. This is a perfect square. So this would turn into 5x the quantity squared minus 1 squared. And there's your difference of squares. So now you can apply the difference of squares formula and get your answer. You do the same thing here. There's a GCF of 2, so factor that out first before you proceed. Same thing with 25, GCF, factor out the GCF and then use the difference of squares formula. Here, there's actually a factor of 2x. So if you factor out a 2x, you'd get 9x to the 9th minus 1. And then I want you to think, can you write this as a difference of squares or maybe a difference of cubes? Think back to other problems we've done where we had 9 as a power. Now, a couple of things to note. Everything up until 26 has had 2 terms. So all the problems until 26, you'll notice, I'm scrolling kind of quickly, but you'll notice all of these questions have only had 2 terms in them. Which is why we only considered the formulas in that box, because these are all the formulas for 2-term problems. Now, the next couple of questions we're looking at are 3 terms. So with 3 terms, these are the 2 formulas we're going to be looking at. These are ones that we've actually seen before. A plus b, the quantity squared, was a squared plus 2ab plus b squared. A minus b, the quantity squared, was a squared minus 2ab plus b squared. So coming back here, looking at 26 onwards, the first thing you want to figure out is, well, always, is there a GCF? This has a coefficient of 1, so the numbers are out. This term doesn't have an x in it, so no variables. How many terms do we have? Well, we have 3 terms. So then I ask, can I use one of the formulas? And for formulas, you always want to see, do the signs match up? So do I have a plus, plus, plus? I do. So here, I'm going to guess that my answer is going to be a plus b, the quantity squared. Now, if this had been x squared minus 4x plus 4, then the signs are plus, minus, plus. Then I would have guessed a minus b, the quantity squared. And you will see this in the very next section, but what happens if you have x squared minus 4x minus 4? Neither formula applies here because the signs have to match up perfectly. What I mean by that is, if you look at the first formula, plus, 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 all the signs are positive. For the second one, we have positive, negative, positive. So either they all have to be positive, in which case you'd use this formula, or it has to be plus, minus, plus. If the signs don't match, neither of these formulas can be used, and then you try doing other stuff, which we will see in the next couple of sections. But for now, in this section, these are the 2 formulas that remain. So coming back here, we hope that this is the formula that has to be used. A plus b, the quantity squared, and this would have given us a squared plus 2ab plus b squared. So what we do is we factor, or we find the square root of x squared, which would just be x. We're using a plus sign because all 3 signs are positive. We find the square root of 4, which would give us 2, and this is our guess. We don't know that this is our answer. We have to check the middle term. So a squared would be x squared, that checks. B squared would be 2 squared, that's 4, so that checks. The thing we have to verify is the 2ab. So if I multiply x by 2, which is going to give us 2x, and then we double that, that gives us 4x, that's exactly what we have in the middle. So I know that this is my answer. I can walk away from this. And similarly, as I was saying earlier, if you have x squared minus 4x plus 4, you know that this answer would be x minus 2 the quantity squared, because we're using the a minus b formula. And the only difference is this has to be a minus there. That's it. Oh, right here. I didn't even notice that that was the very next problem, but these questions often will come in pairs, in that you do all the plus ones first, and then you do the plus, minus, plus next. Let's look at 31 just because the numbers look a little angrier. Here we have a coefficient of 1, so no numbers can be the GCF. We also have, this term doesn't have an A, so I can't factor an A out. This term doesn't have a B, so I can't factor a B out, so no GCF. Then we ask ourselves how many terms? Well, we have 3 terms. With 3 terms, can I use one of the formulas? I look at the signs. I have a plus and then a minus and then a plus. So I'm guessing this could potentially turn out to be the A minus B squared formula. And the way we do it is we find the square root of 81A squared, which would be 9A, minus, then I take the square root of B squared, which would just be B. And then we have to check the middle term. Well, if I multiply 9A by B, I get 9AB. Nothing really mixes there. And if we double that, we get 18AB, which is exactly what we have in the middle. So I know this answer is correct. I can walk away from it. And in fact, if I know how to solve this problem, I know how to solve this one as well. This one would just be 9A plus B, the quantity squared, because again, the formulas have the same terms algebraically, but the signs on the middle term are different. That's all. And just for the sake of variety, we can do this one. 9, the only factor of 9 is 3 and 3. 3 doesn't go into 100, so there's no GCF as far as numbers go. This doesn't have an X, this doesn't have a Y, so there's no GCF. And we ask ourselves, how many terms? Well, we have 3 terms. So we find the square root of 100, X squared, that will be 10X. Minus, because there's a minus in the middle, so we have to use the A minus B formula. The square root of 9y to the 4th would be 9y squared, And then we check the middle term, the 2ab term. 10x times 9y squared would be 90x. Wait a second, this should be 3, I'm sorry. Square root of 9 is 3. Okay, so now it makes sense. 10x times 3y squared would be 30xy squared. And if we double this, we're going to get 60xy squared, which is exactly what we have there. So this is my answer. You know, this is correct. I can walk away from it. And that's the end of the section. So again, just to recap, always factor out the GCF first. If there is a GCF, factor it out. If there's no GCF, or you factored it out already, ask yourself how many terms. You have 2 terms, use all of these formulas and check to see which one works. If you have 3 terms, try these 2 formulas. If those 2 formulas don't work, we'll see what we have to do in the very next section. We'll be going down this pathway and coming here. So see you guys in the next video.